Okay, so let's look into the other thresholds and configurations that we have. So we come to the fundamental meaning engine, and from here you cannot change the internal scoring mechanism of the fundamental meaning engine, but all you can say is whether the fundamental meaning engine will identify intents using the label words or not. We have seen by default this is enabled, which means if the utterance of the user contains the words which are used in the task name, fundamental meaning engine will identify that task as a matching task or an identified intent. Whether it is a possible match or a definite match depends on the total number of words in the utterance of the user, and out of that how many are matching with the label words. But that is different, but still because of this particular property, fundamental meaning engine will identify a task using the label words in the task name. At times this can create a problem because there might be situation where multiple tasks have the same word. Okay, so there are bots where the task names have the same words like open account, close account, something like that. You have two separate tasks in your bot, let's say open account and close account. So this particular word account is common in both these tasks. So you will see fundamental meaning engine, just because one of the words is common, can incorrectly identify another task also. Okay, so in that case, if you want to stop this identification, in that case you can disable it from here. So once it is disabled, then fundamental meaning engine will only identify tasks using the patterns. Okay, so this label word matching will be disabled, and from 7.3 there is an implicit pattern that will be automatically added to the fundamental meaning engine, and that pattern is using the task name. Okay, so there will be, once you disable this, then for the particular task implicitly there will be a pattern that will be added which will have those two words in the task name. So in that case, fundamental meaning engine, if the utterance of the user has the words, will be able to identify that particular task. So that's all you can control for the fundamental meaning engine from the thresholds and configuration, that is whether to use the label words to identify intents or not. When you come to the knowledge graph engine, there are a few more things that you can use over here, but the most important things as a developer that you need to know is whether what is path coverage, what is minimum and definitive level for knowledge task. Now path coverage means in a given in the ontology, uh, partial path coverage will be acceptable or not. That means, let's say yesterday you'll have seen a situation where we had something like this. We had a path called loan followed by car, and there were questions associated by to this particular path. There was another path called loan followed by home. Okay, now these were the two paths. Now you can see over here in the thresholds and configuration, path coverage is partial. That means if 50% of the domain terms are present in the utterance of the user, that path stands to be qualified. Okay, so you can see there are two domain terms in this particular path. There are another two domain terms in this particular path. 50% qualification means if any one of these words are present in the utterance of the user, then this entire path stands to be qualified. So as a result of which, yesterday you'll have seen a situation where if the user's question was, what is a pre-approved loan? Okay, before I made these terms mandatory, when we had said what is a pre-approved loan, both of these paths got qualified and KG had picked up the related questions from both of these paths. How did that happen? Because one of the terms is not present and the questions are associated with the second term. So it is because of this particular setting, that is the 50% of path qualification, 50% nodes in path qualification, due to which out of two words, one word was present, the entire path got qualified, and all the questions which are associated with these path, with this particular path, got qualified for the KG engine. If you want it to be more restrictive, you can increase it over here. So you can increase it to 75% if you want that a little more than 50% of the domain terms has to be present in the utterance of the user. Or if you want that all the domain terms have to be present in the utterance of the user, you can make it 100% path qualification. So only when all those words which are used to qualify your path, they are present in the user utterance, then only that entire path stands to be qualified and the questions are available to the knowledge graph engine. Okay. The default setting is 50% because we have found this is a very good settings. It is allowing partial qualification. Beyond this, if you want to make a particular term as a mandatory term, you can just go and make it mandatory. So that helps you in qualifying a particular path using the mandatory terms. But for those paths where we do not have any mandatory terms, 50% match is good enough to qualify that entire path. But if required, you can increase it over here. Minimum definitive levels for knowledge graph. If the similarity between the utterance of the user and the utterance and the question which is stored within a particular path matches by 60 to 80%, it is taken as a possible match. 80% above similarity between the FAQ and the utterance of the user is taken as a definite match. If the similarity is 95% or more, that FAQ gets a precedence over any other FAQ that might have been qualified as a definite match. That means, let's say an utterance of the user has resulted in 2 FAQs getting qualified. Okay. Now, one of the FAQs has got a score, a similarity score of, let's say, 82%. Another FAQ got a score of 96%. Now, since it is 82% as per this threshold, that is also a definite match. And the one which has got 96%, that is also a definite match. So, going by the logic, if more than one definite matches result, in that case, ranking and resolver should display both of them to the end user, allowing the end user to select the one he wants to proceed with. But for the knowledge graph engine, there is an additional qualification over here. That is, if any of the FAQs get a similarity score of more than 95%, that gets a precedence. So you will see the FAQ that has got a score of 96% or something, the response of that FAQ is displayed back to the end user because that gets a precedence over any other FAQ or intent which has been identified as a definite match. Okay, and it is because of this particular settings. KG suggestion count, if more than one KG, if FAQs qualify, then KG will display maximum 3 FAQs to the user to select from, and the difference between the scores of these 3 FAQs should be within 5%. Okay, so 5% of the top score, it will pick up all those 3 as a qualified match and send it to the ranking and the resolver engine. Then you have manage long responses. At times, the response of a KG is very long. Okay, so the response is too big to be displayed on a particular channel, maybe the mobile channel. Okay, so if the user is talking using the mobile to the bot and the response is too big, it's not very good to display the entire response at one go. So if you want to show the initial section followed by a read more link, okay, so then you can enable that read more link from here. Search and answer is a special use case where usually how the KG engine works is first the path qualification takes place. After a particular path qualifies, KG looks for a similar question within all the questions which are associated with that path. And depending on the score it gives and it falls within whatever threshold, a question gets qualified. Okay. There can be situations, special situations, where all the domain terms are present due to which a path got qualified. But after that, within that path, there are no questions which get a score to get qualified. Okay, so all the questions do not match with the utterance of the user. If you want the KG engine in this situation also to look into the responses, so that if there are any section in any of the responses which matches with the utterance of the user, so maybe that is a possible response of what the user is asking for. So you can enable search from answer in answer over here. By default, KG does not look in the answer, it only looks into the questions for similarity within the path that is qualified. But once again, if you want to force KG to look into the responses also, if none of the FAQs qualify, then you have to enable it from here. And if a matching response is found, if some words in any of the responses are matching with the utterance of the user, you want to inform the user that maybe this is a possible answer you are looking for, then you can enable this, inform end user that this is a possible answer. Click on manage response and you can see this is the response that the bot will display. Here is an answer you may be interested in, followed by the entire response. You can add your own response also over here. And then do you want to display the entire response, or you want to display only the relevant section which has matched with the utterance of the user, or you want to display the relevant section with a read more link, clicking on which the entire response will be displayed to the user. Okay, so you can enable it, but this is a very special use case which some of the enterprises, they want to enable it. By default, this is disabled. Okay, and contextual path is a part of our advanced training discussion. The other settings that you can do over here is for KG is auto correction. Typically, a particular path gets qualified if the domain term matches exactly with the way it is mentioned in the path. Okay, so if there is a misspelling, KG is not going to auto correct it. But if you want to force KG to autocorrect it to the nearest domain term in the bot ontology, you can enable that from here. Bot synonyms, the synonyms that you have defined over here, they are not used by the knowledge graph engine. These synonyms are only used by the fundamental meaning engine by default. But if you want KG along with the synonyms which are mentioned for KG, you also want KG to use the synonyms which are defined over here, then you can enable the use of bot synonyms from here. Okay, and lemmatization using part of speech, that means when it is converting into the basic form, it should be the lemmatized words. That means that ing, ed, so all these words which are preceding the actual word, or which is following the actual word, we cut off those when we deduct the token, the actual word from the utterance of the user. So there are two ways of doing it. One is stemming, which is just going to remove that ing, ed, or something like that. At times that can result in a word which does not have any meaning. Lemmatization, after removing those kind of prefixes or suffixes, ensures that the word is a meaningful word. Okay, so we follow the process of lemmatization on our platform, and lemmatization should also be followed by the knowledge graph engine. Please don't make any change to this particular setting. It has to be enabled. Okay, so don't make changes. Right now we have this setting over here because this has come from 7.3, and whichever client has built the bot in the previous versions, when they are migrating to this platform, we want to enable this particular feature on those bots as well. So that is why we have this feature here. But as a developer in 7.3, make sure that you don't make any changes over here. The other thing that we can do, threshold and configuration, is for the machine learning engine. Machine learning engine does not use the synonyms. These are used by the fundamental meaning engine. But if you want machine learning engine also to use the synonyms, you can enable it here. Stop words can be enabled by the machine learning engine. That is, when machine learning engine is finding the similarity between the training utterances and the user utterance, if there are some words in the utterance of the user which should not be used by ML for intent qualification, it should be discarded by the ML engine. So those are referred to as a stop word. So you can see the list of stop words by clicking on this manage, and it will show you the list of all the stop words with which our platform has already been trained, you can add your own list of stop words. And once a stop word list is enabled, then if the utterance of the user has any one of these words, this word will be discarded. So ML Engine is not going to score an intent on the basis of the presence of these words in the utterance of the user. By default, stop words are disabled. ML definitive score. So if a particular utterance matches by more 95% or more with the user utterance, then it is taken as a definite match, and 80 to 95% is also taken as a match. Okay, so it is a possible match, and ML Engine will forward the score to the ranking and the resolver engine. Okay. The n-gram sequence, it is very important to understand what is the n-gram sequence. So before we take a break, just let me quickly explain what is the n-gram sequence. Now let's say you have an utterance like this. Now this is the training utterance that you have put for the check balance. Okay, now how does internally the ML engine works with this particular utterance? Okay, so you will see the default n-gram sequence is 1. That means ML engine is going to create unigram tokens. That means tokens of one word each from the training utterance. So the first token over here will be available. Okay, the second token over here will be cache. The third token will be in, the fourth token will be account. So in this way, it is going to create single gram tokens of all the utterances with which you have trained this particular intent. And then when an utterance comes from the user, it will see how many of these tokens are present in the utterance of the user and how many times each of these tokens are present. So depending on that, it will give a scoring to the intent for which this particular utterances has been trained. So that is how it finds out the similarity. And that is the reason if ML engine even gets one word matching, then also it can incorrectly identify a particular task. That is because it looks for the presence of the token. It does not look for the entire utterance, whether it is matching with the utterance of the user. It just looks for how many times a particular token is present. Okay. If you go in for the bigram approach for the training the ML engine, then unigram tokens will be created. Along with that, it will create bigram tokens. That means tokens of two words. So available cache, cache in, and in account. And then it will see how many times these tokens are present in the utterance of the user, and depending on that it will give a score. Similarly, trigram tokens will create for each utterance with which you have trained an intent. For each utterance it will create unigram, it will create bigram, and it will create trigram. That means 3-word tokens. And quadragram means all the previous grams along with that tokens which have 4 words in each token. Now, the advantage of going for a higher token, higher n-gram approaches, the number of tokens increase, and that gives a higher possibility of the ML engine to identify a particular intent, because if the higher number of tokens are there, there is all possibility more tokens match with the utterance of the user. So that will give rise to the possibility of an intent getting identified by the ML engine. Okay, but the training time also increases significantly over here, because for each utterance it will create that many number of tokens. So today if you are training each intent with, let's assume, even 30 to 40 utterances, then all those utterances will be tokenized following the n-gram sequence. Okay, so that increases the training time, but of course it improves the working of the ML engine also. Any score below 30% match is discarded. So that intent is not qualified by the ML engine. And NER model, once again, no, don't change over here. Earlier, we used to follow the deep neural network, which needs more training utterances to train the ML engine with the different positions in which a particular entity value can come. But right now, we follow conditional random field algorithm, which requires lesser number of training utterances. Okay, so please don't make change in this. This is once again used for migrating the bots which are created in older versions of the bots platform to the recent version. NER is named entity recognition. I have already said these things, maybe you have missed it out. Named entity recognition. Okay. And entity placeholder, when you are going in for the NER tagging, internally, the position that you have tagged for an entity value, that gets replaced with the name of the entity. So it does not matter. So if I have added an utterance like open savings account and that savings word has been tagged with the entity account type, internally ML Engine will replace that particular word with that entity, so that if an utterance of the user matches with this particular utterance, then ML Engine knows that this position is for that particular entity. So that entity placeholders are enabled on the platform from here. So these are the different thresholds that you can configure for the NLP engines, but be careful when you're making these changes because it directly affects the working of the NLP engine. Okay, if you're not happy, you can always reset it to the default value by clicking on the reset button. Okay, any questions on this?